Hello everyone, and thank you Nora for kicking off this event. So today I'm going to give you some introduction about mobile application security and some hands-on experience how I hacked ParkMan in one occasion. And if you are really a hardcore technical guy that wants today's technical fix on a super exciting shell exploit or something like that, now's the good time to take the dog out for a walk because I'm not going there. This is a presentation more on a higher level, talking about the topics, how the mobile applications work, on the principles behind it, how stuff is made, what are the balances when you create a mobile application, the pitfalls, and so on. And the exploit in this presentation is really simple to everyone here. If I would talk about the exploitation with a technical guy, it would be something like, I found a vulnerability and I exploited it, and the guy saying cool, and that's it. So let's get to topic. About me, I've been on IT business for a long time, and I think it's the same case with pretty many of us, so that I didn't really understand that I'm in the cybersecurity business, but I was always looking for issues and ways to break things and ways to misuse services, and finding lots of problems. And later on, I understood that okay, well, this is something you can do for a living. And I realized that I'm not on the IT business. I'm on the business for security and breaking stuff. So I've been in multiple roles, but the work part isn't that important to me. It's about doing stuff that you love. So on my talk, it's about web page versus mobile app. What are the differences? How do they differ? What is the huge differentiating factor on those two? What's the infrastructure like on the mobile application? How mobile applications work? What is the magic? What are the downfalls? What you should avoid? What you should know about if you're, for example, in a bug bounty program trying to find vulnerabilities in a mobile application. And there's super interesting stuff also. I will go all the way to monitoring your mobile application service. So as I promised, this is not super technical. So how the web page works: you open your computer, you open your browser, you type in, for example, mybank.com, and your computer makes the magic. It resolves where is this service, and it creates a request that my user wants to have the front page. The request goes through the internet to the load balancer, which directs the request to web server. And the web server will take a look at the request. Okay, this user wants the front page. Great. So it will ask one service, could you give me this part of the service so that I can send it to the user? And the service goes, okay, right away. Fetches the database, what's on that part of the web page, fetches stuff from a storage, and gives it back to the service, gives it back to the web server, and other services do the same stuff for other parts. There might be some insurance part on the web page that is wanted to be shown. So there's a lot of services, and the web page creates one response from those. Once that's ready, it makes a nice little package and sends it the same path back to the computer, which gives it to the web browser. And the browser makes it create a nice looking page for you to see and take a look. So when you click something, it's just a link to another place, and the same thing goes on. And the only thing when you are clicking stuff when you log in, for example, that's the active part where you send something to the backend. So the browser takes what you put on the username and password and send it to the web server, which all again ask for a service. Is this authentication okay? Is this user authorized to use our service? Which checks on the database, and yes, he is authenticated, authorized, everything checks, and the web server sends the response back. So on the mobile applications, the huge difference is that you're using phone. It's pretty much the same. Of course, it can be different. You can have a static application so that the application doesn't have to communicate anywhere. But on the most cases, it does have. So the principle is the same. You open the application right away. It checks, okay, it goes back to the server, which receives the HTTP request, opens it up and takes the parameters inside it and sends to services which make the actions wanted and fetch the data needed and sends it back. The big difference here is that the mobile application has or can have lots of more static content. So you can have the layout static, so you don't have to load it every time. It's your application. You can define that these pictures are in the application, but they don't have to be. So you can also download them from the backend or wherever you want. But its basic principle behind the both is pretty much the same. And this is a really interesting part that really makes it clear that the application itself should only be the presentation layer, pretty much the same as with the web page. Your browser is just a presentation layer, but it's way easier to use the application to do some stuff you would normally with the web pages by default do on the web server. The mobile application is luring you in to do more decisions on the application, store more data on the application, some secrets stored in the application, and that's the balance here that you need to find. So if you, for example, you have an application that depends on you calculating pi to the trillionth decimal. So it means that, yes, you have to have computation power. It means that you can either calculate it back here on some service and send the result to the application. But that, of course, means that you will end up with a need for more computation power on the back end, and that costs money. So it's tempting to use the mobile application to create calculate that pi to the trillionth decimal. So if you use the mobile phone, it's of course out of your hands, and the user's mobile phone will calculate it. It will be slower, but you don't have to put so much money and resources on the back end. And depending on how important that result is, defines where you should do it, or is one factor on defining that. So if it has to be exactly, and you just have to have it right, or everything breaks up. The world as we know ends. You can't do that on the mobile phone because it's not under your control. It's under the user's control. So if you want to have the correct exact answer, you need to do it yourself on the back end. So for example, if you have a web or mobile application for banking service, which all of us have, I'm pretty sure you do not have any business logic on the mobile application. It's all on the back end. So if you notice that it's your mobile application telling the back end of that application how much money you have on the account, it's it would be interesting consequences on that. So there's always the balance, what to do and where. So on the mobile applications, one of the biggest pitfalls is that it's really not necessarily understood what the attacker bypasses by default. So we have this connection I overviewed, and if someone wants to attack your backend, he's right away bypassing the application itself. So no attacker uses the application itself to attack your environment. There's either a real hardware phone with internet connections goes through the computer, and you capture all of the traffic and manipulate it as you want, or the mobile phone is an emulator to begin with. So the application itself, it really doesn't matter. It's not the important thing. It's for an attacker. The application is just a guide to the application backend. It tells you how the communication works, what are the parameters, how stuff is done, and in many cases it just spills the beans on secrets right away. So the mobile phone is the part on the service chain that shouldn't matter even for you, even though it's your application. It should be done in a way that if someone takes a look at the traffic, he gets nothing. And by reverse engineering the application, the attacker should get nothing. Only thing the attacker or interested party should gain by reverse engineering the application should be access to his own account and nothing else. So now that we covered that part, and we know the infrastructure, so let's add something bit more here. So this is the chain. Communication goes, your application which connects to the backend, to the services, to the database. And of course, there's always a support services like customer care web app. And then there's the employees who use those support services. There's CRM, ERP, customer care web app, stuff like that. I made it as simple as possible so that it's understandable. And this is the request. This is the interesting part. When you open the application or push a button on the application, what the application does is send the HTTP request to the backend. And this request is a post request, and it goes to this endpoint. Depending on what button you press, the endpoint will change where the connection goes, depending on what the application wants. So you have lots of parameters, and this is the thing that differs in a web browser. You are sending data back and requesting right away because the application knows what it wants. It knows where to get it, and the backend is just waiting. What does the application connecting here want? And gets the parameters. Okay, this request wants to get me to fetch hidden polygons also because it's one. Okay, yeah, I'll give it to him. And some parameters are for the backend to store or use in some way, like duration in milliseconds, 144 to monitor how the application is working, how long some actions take on the application, and so on. And gives the information that, okay, user is using an iPhone. Model is iPhone, operating system version is 11.4 and stuff like that, so that we know and can understand what models to support, where is the user base, what is the most used phone models, and so on. And what was the time request was made. This is also important, especially in the parking business, because you really can't let the end device to tell that I parked for 2 hours. You have to calculate it in the back end. Okay, start parking came at this time, end parking came that time. So the user was parked for this amount of time. So there's a lot more going to the back end, like the accurate location where you are, so that the application knows to fetch correct parking garages, give you information, what price there are, and so on. So, and based on this data, we get an answer. So the backend sends stuff back. And on this request, because we wanted the user data, the application gets the user data, so it can update on the application your own profile. So it tells you that your name is Peter Parker, aka Spidey, and you own us almost $1,000, which makes sense. He's always broke. It tells lots of stuff which the application stores and is used as your own information. So you open a application, go to your own information. That information is fetched from the backend and stored on your device and shown to you. If you make a change, it updates to the backend. It doesn't store in your device only. At least it shouldn't in any application. It's a bad place to store a user data. So if you store the user data on the device and sync it or just store it there, it's not a good practice because it's not stored centrally in the backend. And this is what it looks for you. So you are on the street and you can see where the parking spots are. So it's just a presentation layer. Should be just a presentation layer. So I parked my car, everything's okay, and that was end of it, right? Well, it would be a short talk if that would be the case, and I'm pretty sure many of you already knows where this is going and how it's going. So I have a more exotic phone than most people. All of the same data as the last time is there, but my phone model, it's a bit different. And yes, it's a HTML attack. So my exotic phone is using a weird phone model. So why is this important? Well, it's important because some of this data is something that tells the backend, I want something. Some of the data is, please update this and store it. And some is just for a information that isn't used. And this is something that is stored. So the exploitation, how it works, is that I have an exotic phone. My phone model is in there. I make a request. It goes all the way to the database and it's stored there now. So what happens next will shock you if you think that something happens because the database is just, I don't care. Of course, it doesn't care about HTML attack because it's in the wrong environment. It's in a wrong context. Database is just that I don't care. I don't give a shit. Come back when you have a SQL injection attack. Then see if I care. So we have a phone model in the database sitting there doing nothing, and everything is fine. Nothing's broken. Nothing has happened until the customer care gets a phone call. It's a totally legit phone call. Hey, I had a issue parking. I think I overpaid or my payment didn't go through. And this is the point where customer care opens their computer and connects to the customer care web app, which in part connects to the database. So the customer care fetches your information. You ask that, could you check if it went through? And customer care connects to the web app and searches for your profile. And of course, they will find it and they get it back. And now the phone model is on the customer care web browser. Finally, it's with someone that truly understands him and truly sees him as he really is, because the database just thought this is just a string among others. But now it's on the web browser, and this is where it gets interesting, because the script here really could be anything. You can download any script you want and it will execute on the customer care workstation. And this is where it gets interesting. The possibilities, what to do. Well, you can have lots of fun. So you can have lots of attempts, for example, because it doesn't show in any way to the customer care that anything is wrong, anything happened. Everything works for him as it should. But you are in control of his browser, basically, and you can do whatever you want. So what went wrong? Well, lots of things. I like this exploit especially because it really needs the full chain, not just from the application to the backend, but it also requires the assistance from an employee working on the ParkMan. And this was a great that showed us a lot of things that needs to be improved. This was way backend has been fixed right away. So the first thing is that the user is connecting through the internet. And as we all know, it's not just internet, it's evil internet. So everything coming from the internet is by default evil. And this creates a bit of tricky situation. So we have our own infrastructure. This is what we trust. This is our application. So that we trust it, it's our application. We made it. So everything coming from our application is by default trusted, right? Well, no, not really. The trust ends here. So beyond this point, you cannot trust anything. Even though it's your own application, you have created it. Once it's outside of your hands, you cannot trust it. So everything beyond this point is something you cannot trust, even your own application, because the attacker may be manipulating the traffic, may be doing whatever he wants to do. So you have to be skeptical on everything coming inside after the internet. So the application itself is out of the trust circle. And there might be some other things that I am missing here. So what went wrong? What would we need more on these points to make it that would have made it possible for us to stop this? Well, first thing first. So of course, web application firewall. So web application firewall, or WAF, is to check the content coming in, all requests, all of the parameters, check them and see if there is some malicious code involved, if there is a cross-site scripting, if there is a SQL injection, and if it detects something like that, it just drops the whole request. It doesn't even go to the load balancers. That's the easy first step, but it's really something you shouldn't rely on as the only point. And on the WAF, it's not just for the traffic filtering. It's really useful also. If you don't want to have a request from North Korea, we don't have parking business in North Korea, at least. So is it okay to have connections from North Korea? Well, no, we can block it, and you can use the WAF for a temporarily block some IP if you want to. You can block access or request to certain endpoints if you have to. If there's a situation that some endpoint needs to be taken down, it's easy to do with the WAF. So you can do it really easy with the WAF, and if you have infrastructure as a code in use, you can have the templates so that all you need to do is to just add a country code, and after that, anyone from that country cannot access your environment anymore. Add the IP there and apply. Anyone from that IP or that IP is banned for now. It shouldn't be, of course, it shouldn't be a long-term solution, but if you have to, if there's a denial of service, for example, and you know that it's coming from this IP, this is the first patch. You can block the IP and then it becomes the cat and mouse, but you buy some time to fix the real issue. The next thing, what the WAF does also should be also done on the service level. So every endpoint the application calls, there can be hundreds of endpoints. There should be sanitation. So do you have a phone number with alphabets? And this is where your application aspect is beneficial, because your application sends the phone number always on this format. So if it deviates in any way, you can just drop it to full request or just send an error or something, because then you know it's not coming from your application. Someone is doing something fishy. And it's in a character level. If it's uppercase character on the email and your application makes everything lowercase, you know that it's malicious. It's not coming from your application. Someone is doing something there. Validation, okay, social security number, format, date, start date before end date, checks like that. So you can do these things on the service level, should do on the service level, and on top of that, use the web application firewall to ensure that these things do not come to your backend. Then there's the limitations, length. You know that the phone number is always this long, and you can add a couple of characters extra. Or you know that your application always sends a variable of this length. It always sends a character string this long, and there's no reason to allow any longer ones to the backend. Because of the attacks, it's always about finding the parameter that has enough room for the exploit. And escaping, it's not on the input. It shouldn't be done on the input, but if your environment is and you're confident that the database is accessed only by the web service, you can escape it right away here so that the browsers in the output aren't in harm's way, but it's not recommended. So recommendation is really to let anything come in. If there's a comment field, just let it in. So you let the evil come to the database level. Of course, you will need to sanitize SQL injections and so on. So the input sanitation validation is not done here. So there are cases where the application is built so that it checks that your email is valid, so that there's @merk, there's a dot, and it tells you that okay, you put a comma here, but you don't have dot. This isn't right. But it's for users to make sure that there's no user error. It cannot be used for the input sanitation in security aspect, because it only ensures that the potential attacker isn't manually using the application and typing in the exploit on comment field. But if the attacker is using a laptop in between, it doesn't care, it bypasses the application completely. So the trust issue with your own application is pretty interesting, and many got it wrong. There are so many applications that have the same issue, that it's our application. Of course, we can trust what comes from there, but it's not the case. Okay, and for output. So as I said, that you should actually allow evil to hit your database and store the inputs as they are. So no matter how many SQL injections or cross-site scripting exploits the attacker puts in the comment field, they should be stored as they are. And the escaping is done on the output. So when the customer care web app fetches the data from the database, that's where the escaping is done. So it doesn't, the browser doesn't execute the payload. So the output escaping for the context where data is used. So you might have a service here that does something for the user input on the operating system level. It has to do some transformation or something. So you have and you have a escaping for HTML format. It does nothing in that case. So if there a command injection, it does nothing. The command injection goes through and gets executed already in here. It doesn't go to the database. So the escaping is done on the output, and the output can happen in the middle of the service chain. And then there's the limiting access from the internet and access to the internet. So the from part is something that most get right. So you have to have firewall, and the internal service cannot be reached from the internet directly. And that's great. That's okay. But many people forget or do not realize that you have to access or limit the access to the internet also, not just from. So for example, if I would have an exploit that is triggered on here, on the customer care web app, and it tries to connect to command control server, the access to the internet is fully allowed. And it gets the connection, and the attacker has the channel to the internal network and has the access to the database and everything. But there's no reason for internal support applications and services to have access to the internet on the full scale. It's easier in this level to just whitelist. Okay, this service really needs to get to the GitHub, so let it get to the GitHub, but nothing else. Okay, this needs to have access to Azure also. Well, let's have it. Let's let it have the access to the Azure. On the employee part, if you have a set of employees who have the access to a sensitive or critical services, so they have full access to the internet? Well, most likely not. So even on the level that the employees themselves manage the access list in a level that, okay, I want to go to hackernews.com. Okay, well, they just type it on the access list and they can go there. There's no chance that they would accidentally allow access to command control channel unless it's really well crafted phishing. So access control to the internet also would be a great idea to have in place to protect your own environment. And now for the visibility. This is one of the favorite topics of mine, and you really need to have visibility, not just for the mobile applications, but also any application you have. And this requires something about ParkMan. So ParkMan has lots of active users, and we have over 500,000 parkings per month. And what this means is that there's over 20 million requests in a month. So that means a lot of requests coming in, and environment is constantly being bombarded. It, of course, creates a challenge for the monitoring, but at the same time, it also gives a great baseline. And mobile application is great in a sense that you have a pretty good baseline. So here you can see real image from the monitoring I took for this presentation. So there is a time, what time of the day, at the middle of the night, it's quiet, and you have how many requests are coming in. And every line is a one endpoint. So here you can see what endpoint is in question. You press one button in the application, this line goes up by one. You press another button, this one goes up a notch. So it's really predictable behavior on the mobile application front because, well, at least for ParkMan. And it's a bit easier, still needs work to be done to get it on the good enough level. And on the next one, we have two major endpoints that gets a shit ton of traffic. So while on the smaller ones get something like 250 requests in a minute, 5 minutes or so, the big ones get over 2,000. And at the bottom, we have top 50 requesters. So there are the IP addresses where these requests are coming from. The anomaly here is, well, it's really easy, it's obvious. Okay, we have one endpoint that has almost 1,000 requests, while it normally is somewhere around 100 or something under 200. It's a huge spike for that. It's almost getting to the big leads where the big boys are. So it's a clear anomaly. Is it meaningful? Well, I don't know yet. But when we take a look at the requesters, there's also a spike. Okay, and it's pretty much the same spike coming from a single IP. Okay, well, maybe it means something because it's all coming from a one IP address. So if we focus on the anomaly here, we can see that this is for that single IP, sorted by the single IP, what it's doing, how many requests is it making, what are the requests, and we can see that this endpoint was get user subscriptions, sharp spike. Okay, well, not really looking as it should. Well, let's drill down more. This is where we can see the profile of the anomaly. So we have the anomaly here and even closer in time, so we can see if there is a time between the requests. And you can see that, okay, there's some requests. Okay, now there's more. Okay, now it doubles. Again, it almost doubles. And once again, it doubles or over. Well, what profile does this hit? Is it a brute force? Well, no, because brute force would just go up and stay on the level where the endpoint can, how much the endpoint can give responses, if not throttled. Is this a brute force trying to be subtle? Well, no, because that would rise to 100 or wherever it's set and stay there. It's just a spike after spike after spike after spike after spike. So what's going on? Well, can the user tap a single button that calls this endpoint over 100 times in a 30 seconds? Well, maybe he can. Is he doing it? Well, we don't have any games in our applications, so not likely. So drilling down and tracking this anomaly really gave a good training or good well, training for us, and it happened to be a bug in the code. So there was one call recursion. So one call times 2 times 2 times 2 and so on. So it was just a normal testing of the updated version. And it was on the testing, the new version was working just fine. Nothing's wrong. Everything works fine. So the version was good on the testing sense, but taking a look what it does really revealed the issue. So is this an issue? Well, one user, no, not an issue, not at all. But what would have happened? If that update would have been deployed to Apple and Google as an update, um, all of our users or the applications distributed to the users would have been starting to behave like that. And if one user already lifts the one endpoint to the level of the big boys of the endpoints, and we can detect it with the 100 user, the backend would be start clogging up. The responses would take time. We would need to scale up the environment that fast. 1,000 users, the backend would really have difficulties to stay up with the demand. 2,000 users, we can't do anything anymore. So all of the applications would be spamming us, and 250,000 users. If they all got it, well, the Amazon would be pissed off also. So it would be pretty huge denial of distributed denial of service. And if we try to keep up and let the environment scale, well, it increases the bill. At the time, we had no way to mitigate these kind of events fast. So we had to, of course, after taking lessons learned, we came up with the mitigation methods for events like these and improved the testing procedures even further. And if this would have happened, the service would be down until fixed. And that's not really happening because you can't just release new update for Apple. It would take something like a week for them to review the releasing update. You are releasing new version. It takes a week for them to review it and give a thumbs up that you can release it. And if we would have a situation like this, it would be pretty much game over. We have all of our Apple users spamming our backend, and of course we would have some mitigation method, but the application on that part, the part of the application using that endpoint would not work, and it would be really bad. So what did happen? No, it was luckily it was just a normal testing, and we noticed it during the testing. So we just postponed the update. No crisis, nothing happened. Uh, no impact at all. But if we would not have the monitoring on the backend as a process in a release testing, we would have missed this completely, and the consequences would have been really dramatic, and it would be pretty much catastrophic for ParkMan. So thank you very much. So if you have any questions you like to talk about mobile application hacking or interested in topics, feel free to contact me. I'm always happy to help and always like to exchange ideas. If you want to take something away from here is that the key points, you can trust your mobile application. It's not your mobile application once the user installs it. You can trust it. The second thing, you can do business decisions on the application. For ParkMan, if someone really finds a way to use a laptop on between the mobile phone and our backend and uses it to park his car for free, finds a vulnerability like that and uses it to park for free, well, it's not going to be even top 10 priority list of mine because it's not feasible for everyone. But if someone finds a way to park for free that everyone can use without an effort, then it's a priority number one. But until that, there's certain things you can accept, certain things you cannot accept, and the consequences of letting the business logic be in the application end is the balance of what you can accept and what you cannot accept. But everything, if possible, everything should be on the back end. So thank you.
Thank you, Jussi, for a nice presentation and talk in general. We have a couple of questions on the chat. First one being, is that promo code in the response active, free parking time?
Might be, but if you're a new user, just put in the promo code Jussi and you will get a free parkings.
Cool. The other question is, what is your view on certificate pinning as a way to limit access to the mobile APIs?
Yeah, that's of course naturally it's a issue you need to consider, but it's certificate peeling is what you gain from it. What's the gain and how big is the impact is something you have to really balance in. So I'm not really saying anything definite for this one.
Cool, no worries. The third question is, do you have a bug bounty program or a vulnerability disclosure program at ParkMan?
Well, you can contact me, and if you want, I can send you a test environment application that you can just try and break. You won't be breaking anything important, so I can give you access, and I already have a few guys who are owned a hoodie or t-shirt. TK, you know who you are. So so there are it's possible to get a free ticket to hack ParkMan if you want to.
Cool. Then another one. Do you currently have any open positions at ParkMan for cybersec roles?
Yeah, well, we're always interested in. Unfortunately, the corona mysteriously, no one figured that if people are not moving, the cars are not parking, it hit us a bit. So I had to withdraw all of my budgeting. But yes, we are always interested in security guys, and I do always need more expertise. So feel free to contact me again.
Cool. Next one. Referring to the recursive request you described, what's the most expensive oops you have experienced at ParkMan?
Most expensive oops. I think, yeah, that this one goes on me because I upgraded the monitoring environment a bit, which ended to accumulate in the bills something like tenfold. It was my whoopsie. The disk was fast. I got to give that. But on the other hand, we actually, I don't recall any major incidents that would have stopped our service in any meaningful way so far. There has been some minor incidents, and we have a good process in place. So if something like this happens, we always take the lessons learned and fix the process that caused it.
Cool. Then we have the final question. Have any of these findings resulted in improving development processes? Was, for example, threat modeling already part of the process?
Yes, absolutely. So one of the issues at ParkMan was that focus was purely on features. So you have your mobile application, you have your service, and you want to improve it. You need new features. Okay, we need a feature like this. We want the users to have even more nicer user experience by adding a feature like this. And it used to be so that security wasn't a part of the feature meetings, the feature development, but now it is. So with every feature, there is also the threat modeling. How is this feature dangerous for us? What are the user inputs into our end? How do we mitigate them? How do we store them? How do we escape them? What is the service level? What code is used? What dependencies there are? So it goes really deep. So uh, even on the infrastructure, you can't just run web server, put it once and let it be. You have to keep it updated. Of course, you have to see and know what dependencies there are and update those, so processes are there.
Cool. I think that was all in regards to the questions for you at this point. Thank you, Jussi, for your presentation. We're going to have a short break next, and after that, Dr. Nestor Syynimä will talk a little bit about spoofing and tampering with Azure ID sign-ins.